Today we're going to learn about direct variations. A direct variation is a graph that goes right through the origin at 0, 0. And remember, origin is at the beginning point where you graph. It's at 0, 0. So I go over 0 on the x-axis, over 0 on the y-axis, and I'm right there. So this would be a direct variation because it went right through that origin. And let's pretend that if this was hours, at 0 hours, I would make 0 money. Because you go way down here, it's there. At 1 hour, I would make $2. Probably need a new job, but that's what this graph means. At 2 hours, I would make $4 right there. And at 3 hours, I would make $6. But the most important thing is at 0, I would make 0. So that means it's a direct variation. Let's look at the second graph. Does the line go right through the origin? Yes, it does. So that would be a direct variation. So this, check, is a direct variation. This one, yep, is. Let's look at this one. Does the line go right through the origin? No, it does not. So that is not a direct variation. And does this one go right through the origin? Nope, it does not go through the origin. So that is not a direct variation. Okay, so that's how you can tell if it's a direct variation by looking at the graph. Now let's take a few notes and learn about the formula. So the formula for a direct variation, so you can be taking notes as I write. So let's look at the formula for direct variation, and that is y equals kx. Now, what this means is when you put numbers in here and you multiply it by the x, it's going to directly vary together. And the word vary means change. So these directly change together. As I put numbers in here, this, like let's say this was a 2 and this was a 3. 2 times 3 is 6, so that changed that. So they're directly varying together. Now, this is very, very similar to slope-intercept form. All right, and we've already discussed that. And slope-intercept form has a slope in it and an intercept, and that is y equals mx plus b. And if you look, they're very, very similar, but for some reason they change it to a k and not an m. So they don't call it slope, they call it a constant of proportionality. So this k is called a constant, and you know that constant means number. So the word constant means number. And so K means constant of proportionality. It's a long word. Make sure I spell it correctly. But it's very, very similar to the slope. They're basically the same thing. This is just saying that it's going to constantly change as everything else is changing. Okay, the only difference between these two, notice, is this has a slope right here, and it has a y-intercept. Okay, and this does not have a y-intercept. And we know that from the graph. Let's go back to the graph. Right here, here's the y-axis, and the line went shoom, right through at y equals 0. It did not go through any of the y numbers. But if you look at this one, it had a y-intercept of 3. So that made it not it didn't make it a direct variation. And the same thing with this one. This goes right through that y-axis at y equal to 4, and that means that it's not a direct variation. So here's the formula, y equals kx. So here are a few examples, and let's see if you can figure out whether or not it's a direct variation. All right, would that be a direct variation? Y. And remember that k is really standing for a number, so that would be the 3, and this is the x. Yes, that would be a direct variation. Let's look at another one. Y equal to negative 2x. Does that follow the same thing? Yes, it does. Y, here's the k, and here's the x. So that would be a direct variation. Let's look at another one. Y equals negative 3x plus 1. Now, is that a direct variation? No, it is not. And the reason it's not a direct variation is it's not in the same format. Y equals kx. Right here, it has a y-intercept. That means that line would go right through the y-axis at 1, not the origin. So that makes it not a direct variation. Let's look at another one. Y equals 1/8 x minus 4. Would that be a direct variation? Nope, it wouldn't. And what ruined it for you here? The -4, right. The -4 makes it not a direct variation. It has to be y equals a number and then an x. That's it. So not this part, not this part. Those ruined it. Okay, and last one. Y equals -5/8 x. Is that a direct variation? Does it look like that? Yes, it does. Y equals kx. And that would be a direct variation. Now let's go back in here and try and see if we can identify the constant of proportionality. So in this one, what would k be equal to? Y equals kx. K would be equal to 3. Right here, y equals kx. K would be equal to -2. The constant of proportionality would be -2. That one doesn't count. That one doesn't count. This one does. What would k be equal to? Yep, -5/8. Very good. All right, we're going to move on, and this time we're going to look at a few more examples and see if it's a direct variation. All right, so this is very similar to what we just did, but it's going to be a little bit more complicated. Okay, here is a formula, and is this a direct variation? Well, the problem is you need to have it be in y equal to kx format. So that is the most important format. So we need to solve for y. We need it to say y equals. So right here, I'm going to try and get y alone. So what's the opposite of times 2? Divide by 2. And whatever you do to one side, do to the other side. 2 divided by 2 is 1. Y equals 4 divided by 2 is 2. And you still have the x there. And -8 divided by 2 is -4. And if you're confused on how to solve for y, that's another video on solving for multi-step equations or one-step equation. You can look up that, solving for y. All right, so here's the formula. Y equals 2x minus 4. Is that a direct variation? No, because it's not y equal to kx. There's this extra information right here. This would go through the y-intercept, the y-axis, excuse me, at -4. So that is not a direct variation. Let's do another one. 1/2 y equal to 3x. Is that a direct variation? I don't know. We'd have to solve for y first. Make it look like this. Okay, let's do that. Here's 1/2 y. I'm going to rewrite the problem down here. So I have the original problem still. And how do you get rid of the 1/2? You can times it by 2. Because 2 times 1/2 is going to be equal to 1, so you have 1y right here. But whatever you do to one side of the equal sign, do to the other side. 2 times 1/2 is just 1y, so you can just write y equal to, and 3x times 2 is 6x. Now, is that a direct variation? Yes, it is, because it would be y equal to kx. It's exactly the format. What would k be equal to? 6. Very good, right here. So that would, yes, be a direct variation. And last one, y times x equals 3. Okay, we have to solve for y. I'm going to rewrite the problem so we have the original problem still. Solve for y. So who's bugging y on this side? X is. Get rid of the x. The opposite of times x is to divide by x. Whatever you do to one side, do to the other side. X divided by x is 1, so that kind of crosses out. And you get y equal to 3 over x. That kind of looks weird. Anytime you have x on the bottom, the answer would be no. It's not a direct variation because you can't have a 0 down here. If you have a 0 down here, it's called undefined, and that wouldn't work. All right, and this is my last page of notes for direct variation. What we're going to do now is we're going to graph some equations, y equal to 2x, and see if that's a direct variation. Just by looking at that, can you tell if it is? Yes, it is. Very good. But let's graph it. All right, when you pick numbers for a t-table, you always want to have a negative, a 0, and a positive. So let's pick the easiest negative I can think of is -1. Always pick a 0, and then the easiest positive I can think of is 1. So these will be our inputs because x is called an input. We're going to input those in here. Y equals 2x. My first input is -1, so put that into the equation right there at x equal to -1. All right, y equals 2 times -1 is -2. So when x equals -2, when x equals -1, y equals -2, and that's the output. Okay, let's do the next one. Next input is 0. Y equals 2x. Input is 0, plug it in, and you get y equal to 2 times 0 is 0. And there it is. Ooh, there's the origin right there. Last one, y equals 2 times x, and the last input is 1. Y equals 2 times 1 is 2, and there's the last output. Okay, we're going to graph this t-table. So here is the y-axis, and here's the x-axis. X equals -1, so start here, go x, -1, and then y is equal to -2, go down 2, and put a dot. So start at the origin, go left 1 and down 2, that's that point. X equals 0, go over 0, and then go up and down 0, there's the origin. And the last one is x equal to 1, go over at 1, and then y is equal to 2, go up 2, and there's the dot. Connect them, make sure you connect the dots. And is that a direct variation? Yes, it is, because if I had graphed it correctly, it would have gone right through that 0, 0. So yes, it is a direct variation. Okay, let's look at a few t-tables and see if they are direct variations. 0, -2, 1, 1, 2, 4, and 3, 7. Now you can graph them or you can look for the origin. This one had 0, 0, so I knew it was a direct variation. Right here at x equal to 0, y was equal to -2. So at x equal to 0, y was -2. That means the graph is going to go through that point. So no, that is not a direct variation. Okay, let's do another one. Let's see, -2, -2, 0, 0, 2, 4. Let me think real quick. Hold on. 2, 4. Okay, is this a direct variation? Yes, it is. Right here, that 0, 0. That means if we were to graph these points, the graph would go right through at 0, 0. So yes, that is a direct variation. And last one, 1, 4, 2, 8, 3, 12, and 4, 16. Is this a direct variation? Well, I don't see a 0, 0, but if I count backwards, 4, 3, 2, 1, 0, going back here, take away 4, take away 4, take away 4, take away 4. Oh, there it is. It actually would go through the origin at 0, 0. So yes, it is a direct variation. So when you're looking for direct variations, you want to look for two things. Number one, does it go through the origin at 0, 0? And number two, is it in the same format as this, y equals kx? And remember that k means constant of proportionality.